Okay, let's get started. Welcome everybody to today's webinar. My name is Mark McHenry. I'm a marketing manager here at Morningstar, and I'm joined here by Doug Grubbs, who is an application sales engineer with us. And today we're going to share with you in this webinar some information and updates about a couple of Morningstar's newer products, TriStar MPPT 600V charge controller and the Morningstar ground fault protection device. Both of these products became available late in Q4. We developed the ground fault protection device product, or GFPD, to support the 600V charge controller because in accordance with U.S. Electric Code, a ground fault protection device is required when you have an array on a dwelling. And just a couple of housekeeping items before we get started. We will be making a recording of this webcast available on our website, so you can take a listen to it. If there's some key points you want to review, or feel free to share, of course, with any colleagues who want to hear what we have to say, but perhaps were unable to attend with us. And also, I just want to remind everyone to text any questions that you might have, and you can text them in the GoToWebinar chat box, which should be on the bottom of your GoToWebinar pane. And at the end of the webinar, as time permits, we will address those questions. And lastly, if you haven't already, I'll remind you to bookmark MorningstarCorp.com, where you can find more information, including data sheets, operating manuals, and white papers that I believe you will find to be very helpful. So let's start with the TriStar MPPT 600V charge controller. Morningstar launched the TriStar MPPT controller family in 2009, and the TriStar MPPT family of controllers has become one of the world's leading PV MPPT controllers. Building off the success and leveraging our engineering experience, we were able to launch the 600V version for high voltage PV arrays. TriStar MPPT 600V leverages our TrackStar MPPT technology and Morningstar's 20 years of power electronics engineering excellence to deliver a PV controller with the widest PV input operating voltage range in the solar industry. TriStar controller that we're talking about here uses advanced power electronics to efficiently utilize higher voltage VOC PV or wind inputs to charge 24, 36, 48, or 60V battery systems. And it's important to note that this controller was designed for 48V battery systems, so this is where you're going to get your best efficiencies, but it can certainly be configured at the other voltages that you see here. When this product first rolled out, you might not have heard about these other voltages other than the 48. So this device is able to harvest the maximum energy from a solar array or wind turbine. The high-speed sweeping algorithm minimizes power loss and provides full visibility of the entire power curve from open circuit to battery voltage, ensuring the maximum power point is chosen over all ambient conditions. So sweeping takes place in less than a quarter of a second. Any shading, temperature changes, or changes in irradiance are going to be accounted for very quickly, and each sweep will recalculate the maximum power point where you're going to provide maximum power or maximum wattage from the array to the battery. So this controller is rated for 60 amps, and this controller does much more than efficiently charge batteries. It also provides remote communications, data logging, adjustability, and metering. In fact, the TriStar MPPT 600V controller is the only 600V PV controller to offer open communication protocols and true Ethernet-enabled functionality. So you see the two pictures on the right of the slide. The small one is the standard version, and the larger one to the right is the version that includes a pre-wired solar and battery DC disconnect box. And to give you an idea of the size, the larger version with the disconnect box is about half a meter tall and weighs 13 kilograms or 28 pounds. And we'll further address the differences between the standard version and the version with the disconnect box a little later in this presentation. And just one other item that I'll point out on this slide, both of these 600V charge controllers that you see here have the optional meter display located on the right on both units. The remote TriStar meter display is also compatible with both of these controllers. And here's a closer look at the specs associated with the TriStar MPPT 600V controller. You can see it has a 3.2 kilowatt power rating, That's the maximum wattage nominal. As I stated earlier, it was designed for a 48-volt battery, but it can be custom programmed to support 24, 36, or 60-volt batteries. The device will current limit up to the 60 amp charging limit. So if you have larger arrays, you'll get a max of 60 amps output, and it will run at full power throughout the day. It has a very wide input operating voltage range from the array. The range is from 100 volts to 520 volts. The controller is passively cooled, so it's very reliable because we don't have to use any fans to push air. Fans can represent a possible point of failure, especially in harsh environments that include dust, humidity, and temperature extremes. And fans also indicate a need to prevent overheating of components due to excessive efficiency losses. And since our controller doesn't have fans, it's important to note that we don't waste any energy to run them or other cooling mechanisms. And lastly, you see here on the slide, we offer 4,500 watts of transient voltage suppression lightning protection. And one of the challenges with developing high voltage controllers is maintaining high efficiency ratings like those of smaller low voltage controllers. So we're pleased to share that the 600 volt controller we're highlighting in this presentation has an efficiency rating of 97.9%. We designed and engineered the device to operate very efficiently at high voltages and full power levels in the range of 300 to 400 volts VMP and output to a 48 volt battery. So we'll take a quick look here at some of the features the 600 volt controller shares with our other MPPT controllers. It offers a very simple dip switch plug and play setup for custom programmability. That means there's not a complex meter menu structure where you have to dig into half a dozen meter menus in order to change settings. We have simple battery profiles set up in the dip switches, and in many cases you don't even need the meter to set it up. You just click a couple of dips and leave it in place and it should be good to go. And you can see here on this slide that we have optional onboard or remote meter options. So the TriStar meter family will be compatible with the 600 volt TriStar MPPT controllers. Like our other MPPT units, you can use the meter hub for up to 15 units in parallel. So you can aggregate the output of up to 15 controllers on one meter display. Last bullet that you see here states that we offer the built-in open communication protocols and true Ethernet functionality for the 600 volt MPPT controllers, just like we do with our TriStar MPPT 60 amp controller that you might be already familiar with. And as I mentioned earlier, the TriStar MPPT 600 volt comes in a standard version and a version including a pre-wired solar and battery DC disconnect box. Before we take a closer look here at the differences between the two versions, let's just look at what is included in both. So both here include a high-low voltage barrier which separates the high 600 volt components and wiring from the low voltage battery side components. The reason why this is important is to inhibit low and high voltage wires from contacting each other, and also to help prevent hand contact from high voltage wires when someone is working on the low voltage battery side. You can see we have a total of 8 conduit knockouts listed here, 4 of half-inch diameter M20 knockouts, 2 1-inch and 2 1 1/4 inch. These are located on the bottom of the sides of the unit, so you can pass conduit through these knockouts and string 4 of these units together and share common ductwork among the controllers. Also, on both versions, you get the 600 volt meter that we spoke about and the remote temperature sensor. So here's a close-up look at the standard version alone. The model ends in 48. This is lightweight and compact. And let me move to the next slide to give you a close-up view of the version with the disconnect.
I just wanted to point out here, I just got talking to someone in New Zealand a little bit ago that really liked on the right side you'll see a nice little handle. It's kind of a curved out niche in the back, so it's easy to handle and pull off a wall and set up. So that's a nice little feature. You notice that little notch on the right side.
Yeah, if you can see that here. So good point, Doug. Thanks for pointing that out.
So it makes it really nice.
And you said folks in New Zealand, you were talking about
just
this,
talked
right?
to them.
Okay, I imagine we have a few of them probably on the line here with us today. We have a pretty good crowd from Australia and New Zealand with us at the moment. Okay, let's move forward here. And now we're taking a look at the controller with the disconnect box. So you can see the model number here ends in DB. In addition to all the features that you get on the standard version here, here's the additional features you get with this DB model. So included is the lockable 600-volt DC 25-amp PV disconnect. You also get a 150-volt 63-amp battery breaker. So that's both a disconnect and a circuit breaker as well. There are 4 bus bars for the positive and negative sides of the solar PV and battery. Thus you have several landing points for your wiring. And we give you 2 DIN rails for the solar PV and battery. This gives you the option of reconfiguring hardware, or if you have 2 strings and you wanted to add a fuse holder, for example, you could do that also. And this device has been designed for grounded systems. We provide you a single pole breaker and disconnect. This can be used in a positive or negative ground configuration. And here's a look at the inside of the controller with the disconnect box. You can see here the PV disconnect switch. Over here on the other side is the battery disconnect breaker. Your DIN rails are here and here. You have your battery terminal blocks, and on the other side you have your PV terminal blocks. And down here you can see the high-low voltage barrier right here. And these balance of system components will make the TriStar MPPT 600-volt controller easier to install. We use Morningstar's advanced 4-stage charging algorithm to optimize battery health. That's bulk, absorption, float, and optional equalize. These are in all of our MPPT products. The device is designed for off-grid use in harsh environments. We use epoxy encapsulated components and conformally coat the circuit boards so we protect against salt, wind, humidity, and extreme temperatures. And again, there's no moving parts, fans, or relays. And one of the biggest benefits of this product is the fact that you are wiring the input voltage at 300 to 400 volts. So this gives you a lot greater distance that you can run wire from the PV array before you have to drop down the voltage to charge the battery. So for that reason, we have a lot of new advantages in terms of economics and time and ease of installation. Examples where people have experienced these benefits include installations of off-grid PV systems in heavily wooded areas. In these types of situations, the distance to make a long run with a thick wire that's necessary for lower voltage controllers is not economically viable. But with this 600-volt controller, you can use small diameter wire and make the radial bends more easily, whereas large diameter wire wouldn't be as accommodating to such bends. Another benefit, you also eliminate combiner boxes, fuses, and any related labor because there's no combiner boxes or fuses required with the MPPT 600-volt controller.
And that's on the array side rather than the battery side. You always have a fuse on the battery side or a breaker. So.
Okay. Thanks for adding clarity to that, Doug. And lastly, I'll just mention on the slide the economic benefits we talked about might start to make sense with wire run distances of 30 meters or 100 feet or more from the array to the controller, where the savings in wire, component, and labor costs offset the additional costs of our 600-volt controller. So you not only have the technical advantages, but you start to experience economic benefits at the 30-meter wire run distance. And concerning the input voltage operating parameters for the 600-volt controller, this graph shows the power limits for battery voltages ranging from 20 volts to 60 volts. You can see the very low input voltage range, solar MPPT tracking starting at 100 volts, wind and hydro tracking starting at battery voltage. The max power will be limited with lower voltages based on battery voltage and the max operating input current of 15 amps. That means that the full power operating range is around 150 volts to 250 volts, depending on the battery voltage. And for higher input voltages and lower battery voltages, the controller can start to derate. Generally, it's not going to derate at all with 48-volt systems. When VOC is greater than 525 volts, the solar MPPT tracking stops and there's no charging. And above 550 volts, the controller shuts down to better protect the electronic components. And 600 volts is the maximum allowable input voltage under any circumstance. So instead of sizing to a maximum VOC at historic low temperatures, you would think more in terms of a maximum operating input VOC of 525 volts. And of course, consideration of cell temperatures should be taken into account. And before I move on, I know we've had a number of questions about this. Doug, how does this slide here relate to string sizing?
So in terms of string sizing, it's a little bit different than what you might be used to. But in terms of size, it's about 3.2 kilowatts for a 48-volt battery. So that means using today's 8 or 9 amp modules, you're typically looking at a single string array for full power. And most of the time we're looking at a max string size of perhaps one less than what you might see with a 600-volt string inverter. This is kind of taking into account this 525-volt operating voltage limit. So if your 600-volt string inverter's maximum string size is like 13, the TriStar MPPT 600-volt controller would usually have a max string size of 12, just as an example. Instead of looking at a max VOC of 600 volts, you want to consider a max operating VOC of 525 volts. So the way this factors out is like having a max VOC of 560 volts instead of 600 volts. This could be adjusted some depending on several factors. We'll have a white paper available soon to go over some factors that could change that a good bit. Of course, like if you're one example is ground mount gets more air circulation, so the cell temperature will be cooler, so operating VOC could be a little bit higher on a ground mount rather than a roof mount. So that kind of thing can affect where you might want to size it to. Basically, you could use log data in the area. That would be helpful for figuring out what your operating VOCs are going to look like. In terms of full power with higher input current, the lowest operating voltage that might be considered is maybe 200 volts or higher for a 48-volt system. And this wider voltage window could be really useful at times. The solar tracking at 100 volts could also be good. We had an array set up here with an inverter, string inverter, which was basically shut off because there was snow on half of the modules, and so we saw it operating really well at about 120 volts, where it wouldn't be able to operate with a typical grid-tied inverter or higher voltage string sizing. So, but some people have considered this low input voltage for someone who wants to start with a really small string and then add one module at a time and not have to worry about reconfiguring their whole system every time they add another module. This is really good for home rural electrification, that kind of thing, where they can just add one module at a time and it makes sense for them. So it's pretty simple.
Okay, thanks for that input, Doug. Let's go ahead and take a look at the next slide here. And regarding communications, Morningstar uses standard open communication protocols and interfaces that are electrically isolated. Almost all of Morningstar's competitors use proprietary protocols and interfaces, and this can result in additional costs, difficulties, and extra time to configure. All of Morningstar's data-enabled controllers use an open industrial data protocol known as MODBUS. But using this type of protocol, we allow third-party software and hardware to easily communicate with our controllers. We don't limit the customer to proprietary hardware to use our system information. And MODBUS is continuing to be chosen as the standard of choice for remote telemetry, power monitoring, and inter-device communication. We believe MODBUS support will allow our products to grow easily with the industry's rapid pace of energy technology development. This protocol is open and ubiquitous in telemetry and SCADA instrumentation. Morningstar uses standard interfaces Ethernet, EIA 485, and RS-232. Like its predecessor, the TriStar MPPT 600V, our 600-volt controller can be used as an Ethernet bridge to an EIA 485 serial network. The controller can connect to 244 devices, enabling support for large daisy chain installation, as in the case of telecom. And next bullet, there is data logging available. Internal daily log values stored in controller memory show a variety of power information, voltage, and current thresholds in the system. It also logs daily events such as faults or maintenance cycles. Real-time data can be accessed remotely, so you can view the operational conditions of the controller through any web browser. And when the 600-volt controllers are networked together, up to 15 controllers can share a single meter using our Meter Hub accessory. Remote monitoring and control by serial interfaces or Ethernet are available. There are some additional communications documents on our website, so if you have any questions about this or if you are in need of more information. And also, we intend to offer more training about remote monitoring in the near future. And coming soon, some additional features that will be added. We're going to be offering a DC transfer switch here, which will give you a way to switch the array from a grid tie inverter to a 600-volt MPPT. So if you have an existing grid tie system, you could use this switch here to redirect power away from the inverter here and over to your controller or controllers, so you could use your array for battery charging. The big point to be made here is that this switch will offer the ability for existing 600-volt PV arrays utilizing grid tie systems to be able to charge batteries without expensive and complicated AC-coupled hardware. And another feature that will be coming soon is additional software that allows the paralleling of up to 4 controllers, as you can see here. So these controllers will communicate via Ethernet. They would track and sweep the maximum power point as if they were one controller. And this is not parallel battery charging. This is input to several controllers in parallel that appear and operate as one very, very large controller. So to a large wind turbine or PV arrays, these controllers would sweep and track as one device. In this example, you could handle up to 12 to 15 kilowatts of input to easily charge a 48-volt battery or even other size batteries. So these, did you want to interject something?
Oh, sure, yeah. Well, we're basically right now we're beta testing a single unit with the wind turbines and hydro. And also, one of the features of the new MPPT controller is the speed that it can track the wild DC input from a rectified DC from a wind turbine. So that really makes it, even with it in parallel Ethernet is very fast communications and will respond immediately to fast changes, with high wind gusts and that sort of thing. So it will track immediately to changes in power levels and voltages needed to by the turbine. So I just wanted to mention that as a bonus. And we're looking at larger turbines that have never been able to have controllers on them before. A lot of people have 6 kilowatt, 10 kilowatt turbines that this will operate with, and that's where we see a really big advantage and future use of the controllers.
Good enough. Okay, so to wrap up these two features that we just talked about, the DC transfer switch and paralleling software, are valuable features that will be coming out soon in 2014. And in summary, the 600-volt controller allows the high-voltage PV array to be used to charge a battery while maintaining the efficiency that people associate with a low-voltage controller. This provides new opportunities for ease of wiring and installation. It allows customers familiar with high-voltage strings to now use this same array wiring with a charge controller. Also offers the same ease of use, accessories, and installation as Morningstar's existing TriStar family of products. And it will offer advanced functionality such as input paralleling up to 12 kilowatts for large PV and wind systems. And it will offer the ability for most existing 600-volt PV arrays utilizing grid-tied systems to be able to charge batteries without expensive AC-coupled hardware. So now that we've talked about the 600-volt controller, now let's take a look at the ground fault protection device. Ground fault protection is used in electrical systems to prevent current from following any unintended paths. It's critical to detect any stray currents and to interrupt or break the circuit until safe operation can be restored. Any current imbalance between the sides of a circuit indicates a ground fault. Morningstar's GFPD or ground fault protection device will detect this condition and break the circuit on both the positive and the negative legs. In the U.S., a ground fault protection device is required by the NEC for PV array applications on residential buildings. To others in other parts of the world, this product serves as a protection device against fire and, to some extent, electric shock. We offer this protection for the 150-volt and the 600-volt versions of our family of charge controllers, and our GFPD can also be coupled with non-Morningstar charge controllers. So if you're familiar with existing GFPD solutions or typical GFPD solutions, the way they usually work is usually a fuse or small breaker is located between where the negative of the system is bonded to the ground. And I'll go to a closer look for you here. So you can see here, looks like the slide just cut off with me. You can see here, upon breaking this point here, is where the ground fault is detected and tripped. And Morningstar takes a different approach. So rather than using a fuse to detect and break the circuit, we actually are monitoring the current all the way through the entire system. And we have our sensor over here, and it works like an AC-based ground fault protection device, like you have in outlets in a bathroom, for example. It monitors currents through the whole system, both the positive and the negative, and if there's an equal flow coming in and out, then there's no problems with the circuit. However, if there is an imbalance, there is a problem somewhere in the system, and Morningstar's breaker will trip and break the connection to the PV array during a fault condition. So our sensor trips at 300 milliamps compared to 1 amp, which is what you will typically find in alternative solutions. It's important to note that Morningstar's solution uses a breaker switch, not a fuse, and I'll elaborate on that a little bit later. So this is a closer look at our current measurement device. It's used with an additional breaker stack that actually performs the disconnect. This wire aperture here is where you would wire the positive and negative, and it would detect the ground fault through an imbalance at that location. And let me use this slide here to highlight the advantages of Morningstar's ground fault protection device. So number one, we provide greater sensitivity with greater accuracy, 300 milliamps, plus or minus 10%. We provide better isolation. Our two-pole breaker switch disconnects both positive and negative conductors of the array, completely disconnecting the array from the controller and the battery. And it's also resettable, so you don't have to replace any fuses. And then lastly, this solution maintains bond to earth ground for the battery loads and the controller. So no warning label is required at the battery. This reduces the chance of hazardous conditions on the battery and the loads. And let me use this next diagram here to show the problems with typical solutions, typical GFPD solutions. Number one, fuses and breakers don't have a great degree of accuracy as compared to our sensor. Also, this solution that you see here doesn't completely isolate the battery and loads from the array voltages. So in this system, the negative terminal of the battery stays connected to the negative terminal of the array. You can follow this path here. So for this alternative solution that you see here, the NEC requires an additional label at the battery warning you of this condition. And also the fuse or low current breaker breaks the bond to ground. So the battery and loads are ungrounded and floating. So for a positive ground fault, this means that battery and loads will float at negative VOC. And lastly, I have to point out for GFPDs that use a fuse that the fuse has to be replaced when there is a ground fault. And replacing fuses can be problematic, especially in remote locations. On this slide, we have here some additional information about our GFPD's features. We have bicolored LED that provides current operating status. We have an audible beeper. There is a test button that can put the system through a test to trip the breaker and make sure the system is functioning properly. The GFPD sheet metal enclosure has conduit knockouts that are aligned with our TriStar MPPT controllers, providing a very easy and snug side-by-side fit, and it's packaged with couplings and pigtails for easy wiring. On this slide here that you see some general specs for the product. It runs off the battery, very low self-consumption of less than half a watt. We send a 12-volt trip signal to the breakers, and that will trip the entire system. Relays are used to trip the system in both the 150-volt and the 600-volt versions of this product, and both versions are UL listed. And here are some additional specs about the GFPD. You'll find these specifications on our website, in the data sheets, and the operation manual. Now here's a closer look at the 150-volt version. You can see here we are breaking both legs. When this trip breaker is thrown, it takes the positive and negative of the array with it. And the 600-volt GFPD is larger but works much the same way as the 150-volt. In this case, we have gang breakers to isolate the positive and the negative of the array. And here's a view of the inside of the device. Over here is the wire aperture that we talked about earlier. The wire goes in through here, and then we have both the positive and negative legs. On this slide, you can see the U.S. retail pricing breakdown for the products we talked about in this presentation. First two listings are the TriStar MPPT 600V controller with and without the disconnect box. Then we have the optional TSMS 600V meter, which is a special version of the TriStar meter that can be used with the 600V controller. And lastly, we have the U.S. retail prices for the two versions of the ground fault protection device. Please remember that these are retail prices listed here, so contact your authorized distributor for more precise pricing information. And to learn more about charge controllers and ground fault protection devices, we invite you to go to our website for more product specs, pictures, data sheets, and operation manuals. And with that, let's go ahead and take a look at the questions that have come in. Let's see if I can drag this over here and open this up. Okay. Let's see what we got here. Okay, so question coming in here from Rodney. Can we parallel two controllers now?
Not yet. We have software that will need to use an Ethernet switch. This will be high-speed communications. Otherwise, it's not a. It works in a master-slave relationship. One controller will take over as the master, and the others will follow. So, in terms of having two in parallel, they'll try to fight each other in terms of tracking the voltage, so it would not work very well. So that's not available. So probably this fall we'll be having that. That we're pretty close to having that completed, the design. So I think that's all going to be ready soon. And that will be available for solar or wind, so that could be useful.
Okay. Thanks very much, Doug, and thanks very much for the question. Another question here: what makes Morningstar's high voltage controller different and better than others?
So typically, to achieve higher power and voltage levels, most MPPT controller manufacturers can use basically brute force to force it to work at these higher power levels, and this means very high efficiency losses, and the efficiency losses turns into overheated components. The 600V TriStar MPPT controller has a completely new topology and advanced power algorithm which delivers better efficiency at higher voltages than has ever been available before. That means you can get longer distance wire runs without losing power due to efficiency or voltage drop. The better efficiency is only one side of the story. This is because efficiency losses become thermal heat, and to deal with all the excess heat, many manufacturers use fans. One MPPT controller manufacturer actually uses 3 fans to keep the electronic components from burning up. The thermal heat losses over time are going to take its toll on the life expectancy of the product, and some manufacturers further try to compensate by using replaceable parts, replaceable circuit boards, fans, FETs. They'll have a D rating above 25C, which further makes it operate at its highest temperature limits, rather than being a conservative engineered choice. So our products are maintenance-free and will last a good 15 years or more in many cases. So we've taken kind of a conservative way of doing things, but a lot of people are looking for reliability for off-grid, so that's where we are focused for 20 years.
Okay, thanks very much, Doug. We're going to take a look at some more questions here. I'm just going to ask them, Doug. I'm not sure that you're going to be able to answer all of these, and some of you might have to take offline, but let's give it a shot here. Here's a question about EMP protection. Let's see, can you give any information about EMP protection? And it looks like a follow-up question also is an EMP, can it be interpreted by the GFI as a fault, or how can it be identified remotely? There's a lot there.
Okay.
Is this something
this is electromagnetic protection, I suppose?
Just see the acronym there, EMP.
Or if it's surge protection.
So if Lowell wants to text anything additional about that, feel free, and we'll be looking for that coming in. Looks like he's sending something in here.
Okay.
It says solar or atomic explosion.
Oh, okay. Well, there's going to be surge protection. That would be like a lightning strike that's built in. You can add additional on the externally. The type of protection we have, as far as I know, does not have, as far as an EMP atomic explosions, I'm not sure how it would be protected against that kind of event. So if I can find more information on that, I'll let you know.
Okay, well put. Let me address some other questions here. There's some questions about can I purchase directly from Morningstar? Actually, our strategy is to market through distribution channels. So if you go to our site and want to try to contact us, we can, depending where you're at, we can, and what you're looking for, we can hook you up with the right distributor. I have another question in here that says, let's see, could a double pole PV disconnect and double pole non-polarized breaker be supplied as standard for Australia and New Zealand markets?
So far we have the standard unit and the single pole disconnect version for a grounded system. We will, if the need is there, we can consider a double pole version at some point. But otherwise, you would have to. The best option might be to provide, put external breakers and external array disconnect, solar disconnect at the input for double pole disconnect needs.
Okay, let's see. We have a question here about minimum VMP. So let me just pose this to Doug, and let's see how we can handle this. What is the minimum VMP for an array for it to be fully functioning?
That's a good question. It will track. It does solar tracking from 100 volts, starting at 100 volts minimum. So I would say you want your minimum VMP to be at least 100 volts. Of course, you can generally not operate at full power at that level. So this would be really a smaller system that you want to add on to later maybe. But I would say the minimum VMP should be 100 volts. And now for wind, it will start operating at battery voltage, and you can when you set it for it can work at lower voltages, but it won't track the solar to lower voltages than 100 volts.
Okay, terrific. Let's see. We addressed that. Here's a question. Let me throw this your way, Doug. Question from Ed says, can the MPPT be used with an ungrounded battery?
Yes, it can be used with an ungrounded battery. Now, as far as your local code requirements, we do not have the ground fault protection for an ungrounded array or ungrounded battery system. So that would have to be supplied separately, possibly, if you need that. But there's no problem with ungrounded systems. It will just basically operate the same, but with no ground in the system.
Okay, thanks very much, Doug. And we have some questions from Stephen associated with input voltage. Can you provide a chart of the charge controller efficiency versus input voltage? And will there be an option to support MPPTs suitable for slower reacting mechanical systems? In other words, or i.e. micro hydro applications. There's a lot there,
okay,
so
sure.
However you want to dive into that one.
Good. So we have some preliminary charts. We can send it to you. We're not really publishing it yet, but we will be publishing it at some point. What we're seeing is that the best efficiency, we have efficiency graphs at 200 volts, 300 volts, and 400 volts. The 300 volts seems to be the best. Then comes the 400 volts, which is not much behind the 300 volts. And the 200 volts is not as, does not perform quite as well. So you're getting maybe 94, 95 at 200 volts, 96 to 97 at 400 volts, and then 97 to 98 at 300 volts. So that kind of gives you pretty good coverage for higher voltages all across the spectrum. But at the lower voltages, it's not as efficient actually than the higher voltages, and also at higher power levels, it maintains the high efficiency for the most part.
Okay, well put. We have a
and as far as tracking micro hydro, we have, you can set it up for a single input, so it will track according to a single input voltage. So you can have it set for to always operate at one input voltage, or the wind hydro setup allows you to adjust the input voltage according to voltage and power levels. So you can set up pairs of voltages, and that's available now on our MSU software. Another thing I wanted to mention, that the MSU software, we just updated that on our website, and that does include the 600 volt MPPT controller configuration for wind and for solar.
Okay, good enough. We have a question here about the transfer switch. A question reads, will the transfer switch be smart, e.g. automatically switch back to the grid inverter once the regulators enter float?
Okay.
So might want to think about this one a little bit.
There might be ways to configure this. A lot of the float charging can be done with an inverter charger, so that might be answered to some extent. We'll have to think about how we can make it smarter. But in terms of automatic response, you can you can turn it on and off automatically at any time with AC input. So it would automatically come on whenever the grid goes down, or you can set up a relay 120 to switch on and off 120 or your AC power, and that would automatically switch it over anytime you want. So you can use external controls to do that, and you might be able to monitor our equipment and decide on that kind of scenario.
Okay, very good. We're I think coming up at the end of our time here, but let's just take one more if we could. I see a question here from Scott. I mean, we've gotten really barraged with a lot of questions here, which is great. And of course, you know, if you want to take anything offline with us, feel free to reach out to us. So yeah, the question here from Scott is, if a slave controller in a multi-controller system fails, will the other remaining controllers continue to operate?
As far as I know, that is the idea, that it would. So if any of the controllers fail, at least the slave, the other ones would continue to operate. The reason this could happen, it might not be valid for wind, especially wind, because it wouldn't be able to handle the wind power anymore. So for that case, it may not be true, but for solar, I think it will continue to operate if one of them shuts off.
Okay. And actually, last question here, maybe this is something to take offline, but there was a question here that Peter asked about what we might see for the future as far as any improvements in the support for SNMP, especially regarding reporting battery voltage and current, etc. So I don't know if there's anything that you have to share about that, Doug, at this point. If you've heard anything about the improvements or how these are being used with regarding SNMP, or if the answer might be, you know, not at this time. Maybe there.
Well, yeah, I don't have it. I'm not sure. I haven't heard of any updates, but you know, I'll let you know if there are any.
Okay, terrific. All right, so yeah, I think we've gone through everything here. Let me just take one quick swipe here because let's see. Well, let's give this one a shot here. We did have one more I see coming. Again, let's see if this is something we can answer here. Can the transfer switch be used to operate as a hybrid system? So when the battery is low, it returns to the grid. So again, that's another transfer switch question.
Yes, well, you can operate it based on the AC input to the transfer switch. So as far as operating the transfer switch, it can be operated at any time, turned on and off, and transferred as you want to. There may be software available for that, so that is a possibility, and it's not out of the question. We do not have that. As far as a hybrid system, we don't have an inverter that would integrate that at this time ourselves, but there may be other inverter manufacturers that would be able to switch on and off AC power or a relay to shut off the AC power that could control the charging at any time.
Let's see. Oh, okay, so let's see. We're about 20 minutes over, but hey, let's keep going.
Oh, it's over?
No, let's keep going. Let's keep going. One more.
One last question.
Okay, could two of these units be paralleled in their output using high current isolation diodes, or would they fight each other while charging?
The outputs of all of our controllers can be paralleled on the output, and we use we always use a temperature sensor and a battery voltage sensor, so they're always tracking the same voltage, and they usually stay in sync pretty well. So there's no problem with both of them operating at once, and when one stops charging, there's no reverse current or anything, so diodes are not necessary.
Okay, terrific. Okay, so with that, let's wrap things up. And hey, we had a lot of fun, Doug, and I appreciate all the great questions here. So folks, make sure to see us next time. Take a look at our website for other webinars and activities that are going to be coming up. And with that, I will conclude the broadcast. Thanks so much. Have a good one.